So today we are going to solve Leetcode 69 problem square root of x. We are given with a non-negative integer x. Return the square root of x rounded down to the nearest integer. The returned integer should be non-negative as well. You must not use any built-in exponent function or operator. So we'll have to keep that in mind. For example, we should not use the pow function, which is a built-in function in Python. Now, the given example is x equal to 4. So the square root of 4 is 2, as we know. So we return 2. Now, uh, if x was 8, then output is 2. How? If we do square root of 8, then it's probably this as the result, so we'll round it off to the nearest integer. By rounding it off, we mean rounding it down to the nearest integer, so 2.8 becomes 2, and 2 is the answer, which is the square root of 8 in our case. Now, how we will solve this question? Let's say we had x equal to 8, and the answer which we have to return is 2. If there was any method which would find us the square root of 8 in the least possible runtime complexity, that would be an approach of a binary search. Let's see how. Let's mark the low and high pointers. So low should start from 1, 2, 3, 4, 5, 6, 7, 8. Let's keep low at this and high at this. Now, if we try to find the mid element, so the mid comes to 4. Now, if we check if 4 square is equal to 8, no, it's not. 16 is not equal to 8. So we reduce our search range by moving the high pointer to mid -1. So the elements towards the high from the mid is discarded. So 5, 6, 7, 8, and also the current mid element will be discarded. High comes here, and we again find the mid element. So mid element comes here. Okay. Now the mid in element is 2. If we check if 2 square is equal to 8, it's not, but it's probably less than or equal to 8. That is 4 is less than equal to 8. So one answer can be to store answer as 2, since it is less than equal to 8. Now the goal here is to find the number which is whose square is just smaller than or equal to 8. Now if we try to get somehow 3, suppose we took answer as 2 and we discarded 1 and 2, so low comes to this. Now you can see low and higher coinciding. Now if we try to find the square of 3, so it's coming to be greater than 8, which won't be the answer in our case. 9 is greater than 8, so we won't be storing. Now since we are not left with any elements to check for, we can safely return 2 as the answer in this case. So that can be a valid approach for this problem, and we have also avoided to use the built-in pow in C++ and Python. Also, we have avoided using the operator uh, of finding the square in which is a built-in operator in Python. So yeah, this can be a valid approach, and also it's pretty efficient since we are discarding the search space by each time we iterate. So it's like logarithmic uh, x, where x is equal to 8. So yeah, this was the approach, and we can code this up. We are in our code editor. Let's assign low and high pointer. Low starting from 1 and high to x. In the meantime, we should also store the answer. Initially, let's say answer to be -1. Now, if we run a loop where low pointer is less than equal to high and get the mid, where mid would be representing the middle element, low plus high by 2. If we check if mid equal to no, we should be also let's store the square of x, square of the middle element, sorry, which will be mid star mid. Now if we check if the square of the mid element is equal to the target, which is x in our case, if it was equal, then we can store answer as the mid. Else if the mid square was smaller than x, we can move the lower half to search for in the higher range. Else we can decrease the higher search space towards the lower end, so high becomes mid -1. Finally we can return our answer. So let's check if this works. Okay, so one test case is failing. Let's see where we are doing it wrong. Okay, the thing is mid square won't be always equal to the given target element. So it should probably be like if the square of the middle element is less than equal to x. So in that case, we would be like storing the answer. And also we can avoid this line of code where we can directly reduce the search range by moving the low to find the just small just uh, us we can means reduce the search range such that we get the element whose square is just smaller than the given target. So like it can be like moving the low to a higher search space. So we can do this, and else part is reducing the higher search space towards the lower end. So let's run this one first, and as you can see it was accepted. Let's submit it. Okay, the square root of 0 is not -1, it's 0. So let's update our answer initially to be 0. Yeah, now I think it should work. And yeah, you can see it worked, and it's pretty efficient as well. So this was it, uh, and I hope to see you in the next video.